Hey leopards, we're back. And today, guys, we are going to talk about permutations and combinations. What? What is that? Well, I'm going to show you guys. They are a fancy name for some specific ways that we calculate some probabilities of large number of events. So let's go take a look. Now, before we can talk about permutations and combinations, guys, we got to talk about the fundamental counting principle. Some of you have kind of already realized this and been doing it without even knowing it, okay? It says if one event can occur in m number of ways and another event can occur in n number of ways, then the total number of ways that both events can occur is m times n. Okay, so think about it like this. Okay, you have 3 shirts and you have 2 pair of pants. Well, how many different outfits can you make? Well, 3 times 2 is 6. There's 6 different outfits that you have when you have 3 shirts and 2 pair of pants. Now, if you have 3 or more events, we're going to calculate the number of ways that events can occur using a factorial. And I'm going to show you guys what that is. Okay, let's go take a look. So what is a factorial? Hey guys, a factorial is just this, okay? It's a positive integer, n, okay? We'll just say some number, and it's the product of the integers from 1 all the way up to that number, okay? So what it looks like is this, and when you guys see this expression, n exclamation point, that means n factorial. That means that right here, okay, notice I got 6 factorial, I'm going to multiply 6 times 5 times 4 times 3 times 2 times 1. Now, guys, right there, we can do that, but let's say we have a larger number. Let's say that we have, like, I don't know, 20, right? Can you guys imagine? It would take a little bit more time to type in 20 times 19 times, blah, blah, right? You guys get it? Okay, so I'm going to show you guys a neat little trick in your calculator. So, go get your calculator. I want you to have it in front of you and walk through this with me. Okay, you guys got your calculators. All right, so guys, I just said, well, what would happen if we calculated a larger number? Okay, so let's see. You know what? Let's type in 20. We're going to say if we had 20 people in a race, how many different ways can those 20 people finish the race? Guys, if we were to actually write all this out, it would take us a while to write it all out, wouldn't it? Okay, so instead we can do 20 factorial, and that will tell us how many different ways they can finish the race. Okay, so in your calculator, check this out. You're going to type in 20, and I'm going to show you where the factorial is. Hit the math button. And then if you guys notice up at the top, okay, there is a header that says PRB. Okay, you're going to go to probability. Now in my calculator, it's the factorial is selection number 4. So if I hit 4, okay, and then on my calculator, it's going to say 20 factorial, and I hit enter, and it gives me this number of 2.43, blah, 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 and then it says e to the 18th. Hey guys, that means that I have to move the decimal place to the right 18 spaces. That's a pretty big number, isn't it? Okay, so I don't know about you guys, but if it would take less time to do the probability, do the factorial than it would to actually do 20 times 19 times 18 times 17. Okay, so why are we doing this, Miss Smith? Here's why we're doing it. Guys, we're going to use the factorial to help us computate combinations and permutations. Here's what that looks like, okay? All right, let me get my handy dandy screen going. All right, permutations. So let's talk about what is a permutation. Hey guys, a permutation is an arrangement of objects where the order is important. I'm going to say that again. Permutations is when the order is important. Okay, so if I ask you guys, how many different ways can you arrange the letters A, B, and C? All right, well, guys, I could write it all out just like I did here. There's 1 way, there's 2, there's 3. You guys see there's 6 different ways. Okay, the reason why order is important. Guys, if A is first, then A can't also be second, right? That would be like AAC. No, we want ABC because there's only one A in there. Okay, so we can arrange these 6 possible different ways. Now, order is important when we talk about letters, when we talk about the placement of a race, okay? The placement of a race, which is where I'm going to show you guys how to calculate the permutations next, okay? Because there is a formula that we can use, okay? So, a permutation is the number of permutations, okay? N is the number of objects that we're actually looking at. R is how many we take at a time. Okay, so what we just did up above, okay, we just took A, B, and C. We took 3 objects, okay, and we're taking all 3 of them at a time, okay? So do you guys see that my formula right here would be NPN? Well, guys, that's the same thing as n factorial, isn't it? Okay, n factorial. So if you guys wanted to test this, if you said, okay, I'm taking 3 objects, okay, all 3 at a time, 3 factorial in your calculator equals 6. Okay, but what happens if we say the number of permutations, like how many different ways? Okay, that's another way to think of it. So permutations, and I'm going to write this in a different color. The number of permutations, that's like how many ways, right? How many ways? Okay, where order is important. Okay, N is the number of objects. R taking the number of objects at a time. Okay, so there's another formula down here. Do you guys see where it says NPR? And then there's this funky thing right here with the factorials. Guys, we're not going to make you do those factorials, but I am going to show you. Your calculator is going to do it for you. Okay, so number of permutations. Can you guys imagine if I ask you how many different ways can you arrange the letters in supercalifragilisticexpialidocious? That's a lot of letters, right? Okay, so we would figure out how many letters. N is the number of letters, okay? How many do we take? Well, we could take all of them at a time, or I could say taking 5 at a time, okay? So in our calculators, it might look like this. Well, let's see. How many letters are in the word supercalifragilisticexpialidocious? Have you Googled it yet? Hey guys, there are 34 letters, okay? So our number of letters would be 34, and I said that we're going to take the first 5, right? So R would equal 5. Okay, so let me show you how to do this in your calculators, okay? We're going to go and we're going to look at the probability underneath the math function, and here's how we're going to do. The first thing you're going to do is you got to type in your value for N. So our N is 34. So in my calculator, I'm going to type in 34. Then I need it to calculate a permutation for me. That's the P. So I'm going to go to math. I'm going to go back to probability. And hey guys, do you see the second one in my calculator says NPR? Oh, I'm going to select that one. Okay, that tells the calculator you're going to do a permutation for me. The N goes before, then the permutation, and then how many times that we want to do the permutation. And we type in 5. And when we do that, hey guys, there, whoa, let's see, how much is that? That is 33,390,720 different ways to arrange the letters in supercalifragilisticexpialidocious using the first 5. That's a lot of different ways. Would you guys want to write all those down? No. So that's why we use the permutation calculation. Now, I'm going to show you guys how we're going to use this in an example here in just a second. Okay, I'm going to work out some problems with you. But what I want you guys to remember, okay, permutations, okay, order matters. Okay, that's the one thing that you really need to remember. In a permutation, the order matters. Okay, all right, let's go look now. What is a combination? All right, well, let's go take a look at the second page of your assignment. Okay, so a combination is a selection of objects where order is not important. I always think about it like a combination pizza. Like when we're making the pizza, guys, it really doesn't matter. Like if we put the pepperoni on first or the hamburger or the mushrooms or the olives, it doesn't matter. Okay. And for those of you that eat pineapple on your pizza, more power to you, right? But it doesn't matter. When we're making the pizza, it doesn't matter what order we put the toppings on. Okay. Another example, right? If we're drawing 3 identical prizes, okay? So the order of the winners is not important because all the winners will receive the same prize. That is a combination, okay? Now, if the prizes were different, okay? So if first, second, and third place got different prizes, then the order would be important, okay? But order is not important when we just say, hey, all 3 winners are going to get a prize. Okay, now, formula. Yes, there's a formula for it, okay? C is the number of combinations, and that's another way of saying, okay, how many possible ways, okay, how many are possible, and remember, with a combination, okay, order does not matter, okay? Order does not matter. All right. So I'm going to write this out for you guys. Hopefully you will write it down as well. Okay, N is the number of objects that we're going to choose, and R is how many we take at a time. Okay, same thing with permutations, except with the combination, our calculator does the calculations in a different way. Okay, in a different way. Okay, so let's do an example real quick. We're going to go down and look at number 4C. Okay, for Charlie, and I'm going to show you guys how we do the combinations in our calculator and how we do permutation probabilities. All right, I'll meet you guys down at number 4. All right, so guys, down here at number 4, we're going to do letter 4C together. We're going to do this one right here. Okay, it says find the number of different ways you can arrange all of the letters in each word, and then how many different ways can you arrange 2 of the letters? Okay, so we have the word scissors. Hey guys, how many letters do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. There's 8 letters. Okay, so how many different ways can we arrange those letters when we're taking all of them? Well, hey guys, that's when we would do the 8 factorial. Okay, so right now in your calculators, I want you to practice how many different ways can we arrange all of the letters in scissors. Okay, did you guys remember in your calculators, you hit 8, math, go over to probability, go down to the factorial, and guys, I get 40,320 different ways that we can arrange those letters. Oh, okay. Again, I wouldn't want to write all those down. Okay, now, what if we just take 2 of the letters? Okay, so if we take 2 of the letters, then is the order important or is the order not important? What do you guys think? The order is important because if we're only taking 2 of the letters, okay, well, we could either take S and C, but then if we do S first, then C can't be first, can it? Okay, so this would be a permutation. Okay, so what do we put in our calculator? All right, we practiced this just a second ago. Okay, so the number of letters is 8, and we are taking 2 at a time, and we're doing a permutation. So in our calculators, we're going to type in 8, and then it's going to be NPR, and then 2. Okay, so we practiced this just a second ago when we did permutations. Can you guys give it a shot and tell me how many different ways can we arrange 2 of the 8 letters? All right, so double check. In your calculators, you type in 8, you hit math, go over to probability, and guys, if you look, the second one down on my calculator is NPR. I select that, and then I type in 2, and I hit enter. And, hey guys, there are 56 different ways that we can arrange 2 of those 8 letters. Again, I would not want to write all those possibilities down. Let's let the calculator do the work for us. Okay, So you guys have got some practice on factorials and with permutation. Remember, order matters. Okay. Okay, let's go down and I'm going to do another one with you guys in number 5. Now, I want you guys to notice something. Okay. I'm going to do this one right here with you. The 12C3. C means combination. Okay, so combination means that order does not matter. Okay, so in my calculator, what does that look like? Well, I would type in, just like right here, I'm going to show you guys on my calculator. I would type in 12, go to math, go over to probability, go down to NCR, okay, select that, and then hit 3, and then enter. So when you guys type that into your calculator, what did you guys get for 12C3? Okay, did you guys get 220? Okay, if not, okay, then we may have to work in class together. Make sure you ask your teacher about how to work these out in your calculators. Okay, guys, let's go down and look at number 10 next. Number 10. All right, guys, down here at number 10. Okay, this is like a real life type of example. And it talks about your choice board project, right? Okay, to complete the choice board project, you must complete 4 out of the 10 possible mini projects. You guys actually did this in the fall and you're going to do it again this spring, right? Okay, now it says, how many different ways can you complete the project? So I want you guys to think about the rules and the instructions for the project. Did the order matter? Yes, the order mattered. You guys had to do level 1 first, and then you could do level 2. And then after you did level 2, you did level 3, right? Okay, so the order did matter. So does that mean that, is this going to be a permutation or a combination? That's right. It's a permutation because order matters, doesn't it? Okay, so if it's a permutation, there's a couple things that we need to figure out. First of all, we need to figure out the number of possibilities to choose from. Okay, so the number to choose from, hey guys, that's going to be your N, isn't it? Okay, and then we need to figure out the number to choose. All right, how many are we going to choose? That is your R. Okay, all right, so the number to choose from. Well, how many total mini projects were there? 10. There's 10 to choose from. And how many of those 10 are you going to choose? 4. Right, you're going to choose 4 out of the 10. Okay, and because it's a permutation, okay, now we can do the calculations. Hey guys, this is how you're going to write down your work. This is how you're going to show your work. Okay, so do you guys remember the formula said NPR, didn't it, for permutations? So we're going to write down 10P4. Okay, 10P4. That's showing our work. Now, you guys are going to go put it in, and you're going to tell me how many different ways could you guys choose 4 out of the 10 projects? Holy cow! That's a lot of different ways that you guys could have chosen your 4 mini projects, right? Did anybody have any idea that it was that many? Okay, so guys, this is a real life example for you guys. And yes, you're going to see questions like this on your SATs and your ACTs. So you want to definitely know what is the difference between a permutation and a combination. Okay, we've practiced some stuff with this. Now, guys, next I'm going to show you on number 12, I'm going to show you how to actually use these permutations to figure out a probability, or maybe it's a combination, to figure out the probability of an event. Let's go look at number 12. Okay, number 12 is another situation to where you guys have probably encountered this in real life before. All right, it says you and your friend are in class together. There's a total of 32 students in the class. Now, students are randomly assigned partners for an activity. What is the probability that you and your friend are chosen to be partners? Okay, now we're going to express that probability now as a fraction, and I'm going to show you guys why here in just a second. Okay, before we do anything, we have to figure out, is this a permutation or a combination? So does the order matter in which partners are chosen, or does the order not matter? What do you guys think? Permutation or combination? Hey guys, it's a combination. The order doesn't matter. They are randomly chosen. It doesn't say that I choose the students whose last names begin with A first and Z next. It doesn't say that. It just says randomly. So order does not matter. Okay, now, how many different ways are there to randomly assign 2 partners out of 32? So we have to figure out, okay, what is our number to choose from? Here's our number to choose from. And how many are we going to choose? Okay, so it says that there are a total of 32 students. That's our number to choose from. And how many are we choosing at a time? 2. We're choosing 2 at a time. Okay, now I want you guys to practice this. You're going to find the number of ways using the combination formula. Okay, so in your calculators, I want you guys to go and figure out what is the number of ways that we can choose 2 students randomly out of 32 to be partners. Okay, did you guys get 496 different ways? Guys, think about it from a teacher's perspective. We have 496 different ways to randomly choose partners. That's a lot. Now, I want to just verify that in your calculators, you guys pushed 32, math, go over to probability, choose the NCR, then hit 2 and hit enter. Okay, so that's just a reminder of how to find that. Okay, now when we talk about the probability, okay, so our total number of ways is 496. Okay, so we're saying out of 496 different ways, what is the probability that you and your friend are chosen? Remember, there's 2 people chosen at once. So there's only one way that me and my friend can be chosen. Okay, so I'm going to say that again. Okay, this right here is me and my friend. Okay, oh my gosh. Y'all look at my and sign. That is something else, isn't it? Okay, so me and my friend, there is only one way that me and my friend are chosen. Otherwise, another way would be me and somebody else, and my friend and somebody else. Okay, or it could be my friend and I. That's one way out of a total of 496. So guys, this right here is our probability. Okay, so expressed as a fraction, we would do 1 over 496. Now, why are we doing that? All right, hey guys, in your calculators right now, I want you to do 1 divided by 496. All right, how many different ways? What's the probability in that? If we multiply that times 100, which I'm doing in my calculator right now, guys, it's like 0.2%. That's a really, that's even less than 1, isn't it? Okay, so when you have a high number, a very high number, guys, leave your probability as a fraction. I want you guys to think back up to, right up here when we did this one, 540 different ways that you can choose your 4 projects. Okay, so if we were to talk about the probability, 1 divided by, 540, 5,040. If we did 1 divided by 5,040, it's going to give us a very, very, very small percentage, and it might even end up being to where it's like 0.0003%. So that's why we're leaving these as a fraction right now. Okay, you guys have got a chance to practice some permutations and combinations. Okay, so think about it. Permutations and combinations are a way for us to figure out how many different ways. What is our sample set? Okay, and then if it says, what is the probability? Okay, then we would use the sample set that we just calculated, and we would find out how many different choices are there out of that permutation and combination. All right, I know permutations and combinations can be a little bit confusing, but we're going to practice them. And guys, as always, you got to ask questions, right? Okay, you guys know the deal. I'll see you guys in class. Adios.